Hi everyone, and welcome to the session. My name is Jason Bonello, and in this session we are going to see how you can start exploring your data using Azure Data Explorer. Just a bit of an introduction about myself. I have worked for over 10 years in different roles within data, mainly through SQL-based business information systems like ERP, data analysis, and also BI projects. I now work as a senior data analytics consultant with Adatis, and we use Microsoft technologies to produce different solutions and projects, including Azure-based solutions like modern data warehousing, visualizations, reports, and also data systems, amongst various other things. Just a quick overview of how the session will be structured. We will start by covering why Azure Data Explorer is beneficial and why it's needed. We will then cover what is Azure Data Explorer and what does it offer. We will see also some use cases and how it can be used. And we will also get a feel of the product through a demo. So let's start with the first part, which is why Azure Data Explorer. So the projects that we work on in data consultancy, for instance, involve dealing with various different sizes of data, different formats of data. They are located in different sources. And all of this basically make up part of the 5 Vs, which are variety, velocity, volume, veracity, and value, which basically make up big data. And in different occasions, we face situations where data that was being ingested or is being ingested at the moment from real time or near real time, they have to go through the entire process of ETL or ELT in some cases for it to be ready for analysis. And in that circumstances, we end up holding up a funnel with data coming in, data being ingested and streamed, but with limited analytical capabilities until all of this data is being loaded inside our data warehouse. So in some cases, we don't even know what that data even holds. And even if there were some tools that might have existed, that basically you can analyze one particular individual file of any data being streamed in, or even other services, even within Azure itself, that allow ad hoc querying on data being streamed in, there was still a missing piece where running analysis and analytics on high volume of streaming data with the intention of, for instance, detecting patterns or doing the likes of trend analysis and getting fast results despite the high volumes of data, also having options to persist, for example, the data and query on it, that particular area was not easy to achieve. Until Azure Data Explorer came into picture. What is then Azure Data Explorer? It is a data analytics service that allows real-time analysis on large volumes of data that is being streamed in from different sources like applications, websites, IoT devices, and it is fast. It is also fully managed, which means that it requires very minimal to no maintenance. You don't really need to do the normal and traditional database administrative tasks like indexing and the likes for you to keep it fast, because all of that is being automated and done for you by the service itself. And Azure Data Explorer allows basically the collection, storage of data, and also it enables us to analyze the diverse data coming in to get to analysis quickly and hence also facilitating decision making as data is being streamed in. So why Azure Data Explorer? So I would say these are already points that we can point out why we can use Data Explorer, because it allows exploration as big data is being streamed in. So we don't really have to wait for the ETL or ELT process to finish. We can immediately use big data and get results and analysis out of it holistically, because the data that we are ingesting and which we can query and analyze, we can see it not only as an individual part and an individual and separate file, but we can use that data and also append it to other ingested data and get basically the whole picture, achieving trends, seeing patterns, getting to anomaly analysis, and all of this because of the way that we can analyze data within Azure Data Explorer. Big data quickly, which means it performs very well on big data. It gets results quickly despite the large volumes, and also in raw format, which means that we don't need to do any transformations before we can start doing the analysis. And hence again why we don't have to wait for any ELT or ETL to start doing analysis on the big data. So in the next section, we'll have a look at what is Azure Data Explorer. So anyone who has used SQL Server Management Studio, basically this very familiar structure of it. So if we have a look here, we can see that on the left, we have the database and the tables inside here. We have also the query pane in here and the results pane at the bottom, and also some similar functions like run at the top and options like file and normal, basically similar stuff to what we see normally in the first screen of SQL Server Management Studio once we open the query analyzer in there. So, is Azure Data Explorer a solution for all problems? The answer, as with any service, is no, it's not a solution for all problems, because obviously each service and tool is targeted to address a particular problem, right? And in this case, in order to understand more what Azure Data Explorer is for, we will start by eliminating those scenarios where Azure Data Explorer does not fit in well for, right? So one of them is data warehousing. So even within Azure itself, we have other technologies that do suit more and do much better job for data warehousing. So we have the likes of Azure Synapse, and even, for instance, Power BI Premium allows us to build data warehousing. So those are more suited for that particular scenario as opposed to Azure Data Explorer. Machine learning. So at least so far, Azure Data Explorer does offer built-in machine learning algorithms for clustering and statistics, but in itself, it is not a machine learning training platform, and it is more suited to do forecasting and predictions on pre-trained model. So basically, if we want to have a platform which we are going to use to train the machine learning models, we then need to utilize other services like, for instance, Azure Machine Learning or technologies like Azure Databricks. However, it can work quite well in conjunction with them to enhance the machine learning area more. Application backend. So it cannot offer the transactional workload that can be offered by, for instance, Azure SQL Database or Cosmos DB. So again, it might not be the best service for that. And extreme real-time accuracy. So we did mention real-time multiple times so far, but basically the very low latency level that it offers on ingestion goes down to seconds rather than milliseconds, for instance. So if anyone is basically requiring latency down to milliseconds, it might be worth a test to ensure that it does fit your particular scenario before you start utilizing this solution. So let's see some use cases that Azure Data Explorer is fit for. One of them is Internet of Things telemetry analysis. So it is definitely a good scenario that will help us in, especially given that it allows instant analysis and data mining as data is flowing in, hence making it possible to append the data coming in with existing information. And again, as we mentioned before, it hence allows us to then do trend analysis and, for instance, anomaly detection and the likes. Log analysis. So imagine if, for instance, a company has different logs for different systems within the company itself, whether they are systems, databases, websites, they might be running on different clouds or even on on-premise or cloud servers. And maybe we need to run unified monitoring analysis on system health. This can easily be achieved through Azure Data Explorer, and it will help us a lot in that area. Just to get also some context on this, if anyone has used the likes of Azure Sentinel or for instance, log analytics within Azure itself, this is using in the backend Azure Data Explorer, right? It also uses the same querying language, which we will see in some more slides down the line, and also the same engine that Azure Data Explorer uses. So we might also be already using Azure Data Explorer without even knowing. Anomaly detection. So if anyone wants to check for suspicious behavior within any, for instance, system or e-commerce website, for instance, this is quite a good scenario that will help us in doing so. Customer behaviors, these can also be analyzed, for instance, understanding seasonal trends, predicting spikes, and based also on historical data and current data, it does fit well that particular scenario. Also, for instance, if anyone wants to assess a customer journey on a website and trying to understand at which point the customers might be leaving the sales process mostly, this is also quite helpful in that regard. And embedding on software as a service solutions. So it does offer a lot of analytical potential in that regard, especially with the ability to ingest and analyze petabytes of data in real time. Developers can also use it to monitor the service and improve application performance, whilst, for instance, other business users can also see how to target and personalize experiences depending on the data that can be analyzed and ingested in real time. Architecture, just to have a bit of an idea, this is a high level architecture to see where Azure Data Explorer fits in. So basically, it will cover the area marked in red, which is the explore. So as data is being ingested in, we can explore the data before storing it and then also getting in that data ready for the following stages like preparation and training and serving that data inside the data warehouse. So that is the part that Azure Data Explorer falls into. And some might say there are still ways to explore terabytes of data in little time, right? So what makes Azure Data Explorer so special and differently powerful? So these are some points that basically will answer those questions, right? So the first one is it does not require defined indexes or pre-computed aggregations. So unlike, for instance, SQL, when we are doing a lot of indexes and SQL, basically database administrative tasks that needs to be done, in Azure Data Explorer, all of this is fully managed and automated in the backend, and it will basically allow us to focus more on analysis. So it allows also a doc query over large data sets in very little time. So again, that is also another plus. It does allow time series analysis. So again, not only focusing on specific files, but also on trends and patterns, hence making more sense of data. And to do this, it allows the data set to be split in multiple series, and one can also analyze each series separately or even as a whole. It also enables analysis over structured, semi-structured like JSON and XML, and some forms of unstructured data. And by what I mean by some forms is that wouldn't include obviously images, but it does include free text, for instance. It also has its own simple querying language, which is kusto query language. It is very easy to understand, and I would say people don't even need to have background of SQL to understand this language. Obviously, it will help if you have SQL in some thoughts and mind frame. However, the syntax is quite different and I would say simpler. And there's a lot of material online, especially the Microsoft official documentation will support you well on this, apart from some courses which we will also point out at the end of the session. And it also offers visualizations built in through different ways. So it has the render function, the KQL command, which one can use and produce various charts like bar chart and column chart or other particular charts. It also has a dashboard functionality, which is currently in preview, but I don't think it will belong till it will become a part of the service out of the box. And also it provides a basis for other visualization tools, and other visualization tools, even like for instance Power BI, can use a Azure Data Explorer in the background and produce reports on top of it. So the next part will be how can it be used. So to start using ADX, there are three simple steps that need to be done. So we need to create a cluster. So I would say this process is similar to if anyone used Azure Databricks. It's quite similar, even if someone hasn't used Azure Databricks before. It is quite an easy step to follow through the portal. One can then create an ADX database, and basically some settings that need to be set during this process are, for instance, the retention period. So how long do we want to hold the data in the database after ingestion? We can set that inside the step, and also setting the caching. So this will determine the hot and the cold tier. Obviously, these particular settings will then affect the pricing of the service. So ideally we suit it for our particular case. And then we create the ingestion. So we can create the ingestion within Azure Data Explorer or even through other means. We'll cover that in a bit. And ultimately we just start querying, right? So once the cluster is up, once we have set all that up, we can then start querying. So to touch on the ingestion methods, we will not go into detail on this, but just to give you an idea. So some ways to do ingestion within Azure Data Explorer are automatically. For instance, within Azure Data Explorer itself, one could do pipelines, ingestion pipelines, and that way we can then productionalize the solution and keep on getting the data not more than once. There are also other ways. For instance, Azure Data Factory does fit well within this. It has Azure Data Explorer activities within it, which will hence allow us to also ingest within an Azure Data Explorer database and also other ways. So some manual ways to ingest the data. So we can push the data, and when I say push the data, it means like we are hard coding the values within the Azure Data Explorer query, KQL query, and inserting them inside the table. It is similar, anyone who has used SQL, it will be similar to insert into in SQL. So pull data, so you can get data directly from source like blob storage using a shared access signature connection. And you can also do query so when I say queries, basically again, just to give an idea, if anyone has used SQL before, it will be similar to select into or insert into select from, but within it has its own KQL commands for those. There are supported data formats. There are many different text, CSV, JSON, Parquet, and it also supports compressed gzip data, for instance, or zipped data. And Azure Data Explorer could be used through two main user interfaces. So it can be used through Azure Portal, and one can also use it through Kusto Explorer desktop tool. So you can download this desktop tool, and it is also a good tool that can connect to your cluster and do the analysis and querying through that tool. So one other feature that Azure Data Explorer offers is external tables. So this is quite similar to Polybase external tables, if anyone has used Azure Data Warehousing or Azure Synapse before. So it allows you to read from, for instance, a blob storage without ingesting the data, and also export your data back to it through the same external table. Obviously, in doing so, you won't be utilizing the best of performance of this tool, because you will not be doing the actual analysis on the ingested data within the engine, the Kusto engine, and it will show also within the list of tables just within its own folder, which will be called external tables. So just to give also some very basic architectures where Azure Data Explorer can fit in, right? So basically, there is no one architecture. However, these are some ideas, right? So for instance, let's imagine we have a website. We can then use Azure Functions to feed to Event Hub, which will queue the data that is being received and send that over to Azure Data Explorer. Event Hub does work quite well on ingestion with Azure Data Explorer, and then you can visualize that data either within Azure Data Explorer itself, or even feed it to Power BI, and for instance have a report that you can refresh over the data, even through direct query if you want. So another idea, so imagine you have IoT sources, whether those are factory plants, fleets of vehicles, appliances, or at homes, and there is like IoT hub that is getting the data, and that data is then again ending up in Azure Data Explorer. You can then do whatever you like within Azure Data Explorer and even export that data, save it inside the blob storage for instance, data scientists to pick up and build Azure machine learning models over them. And you can also, in the meantime, feed any data, if you want, to Power BI separately. So those are all ideas of how Azure Data Explorer can fit in, even within existing data architectures. So to touch base the Kusto query language that we mentioned, so this is quite powerful language, I would say, in the sense that it allows relational query capabilities, whether they are aggregations, whether it is filtering, selections, joins, calculated columns, even window functions, like for instance, summarizing and aggregating data by a particular attribute. It allows text searching and parsing. So within, for instance, a semi-structured or free text file, you would be able to find particular text. Data typing, so it has what we normally have in for instance, other languages like SQL. So it does differentiate between string, number, Boolean, and other data types. So it allows variables and functions. You can basically save a function that you can then refer to again and use over and over again without having to reproduce every time all the commands and queries. It enables export, so you can save the results that you get or the query itself. And also, it is user-friendly and intuitive. So when you are typing the query, for instance, the IntelliSense is very helpful to give you the potential commands that will fit in that particular scenario. And as you are building the query, you can choose your preferred next step. So just to give you an idea of the KQL query structure, so let's imagine we have a particular table which is named departmental sales, which holds the sales for each department within the company. And we need to summarize that data and be able to get a total amount of sales by each department name, right? So that's what we are doing in the first line, and then we are sorting the results by department name, filtering out where sales are greater than 0, and selecting only 3 specific fields. So we are getting back the name of the department, the sales amount, and total sales amount. And we are then also rendering a column chart. So in here, we can see basically the table name that always is the first point of a KQL query, the pipe, which indicates another action or another predicate that is going to be done on a table, and the operators will start just after the pipe. Will then be specialized, specifying what each operator we are going to use in that particular action that we need to do, right? So this is just an idea of a KQL query. Anyone who has some knowledge in SQL, just to also give you a picture on this. So for instance, on the right in red, we have that query, which is in SQL. We want to get all the data from departmental sales. In KQL, in this case, we'll only write the name of the table. And if we execute that, it will achieve the same results. If we were to get specific attributes or columns from a particular table, all we need to do inside KQL is the name of the table, the pipe operator, and then basically specify which particular fields we want to get back. And here's an example of a windowed function. So if we were to get the sum of sales, doing an alias as total sales amount from the departmental sales table, grouping them by the name, and basically filtering out all those that have sales. This is basically how we would do it inside KQL. So obviously, this is just an idea to give you a picture of how KQL language will work in these circumstances. So if anyone is basically more familiar with SQL and is still sort of not quite sure of how they can shift to KQL, another thing that one needs to or can use is the operator explain. So we'll see here. So in itself, Azure Data Explorer does accept a SQL query, so you can execute a SQL query. It will not basically cover all the operators that SQL can offer. but it does cover a lot of the basic queries. So for instance, here I'm doing a windowed function over a particular table to get the data from it. If I execute that in SQL, here, as you can see, it is running and we can get the data back in the same way that we would have got that data in KQL. However, if I want to transform that data, that query, and use a KQL query next time, I will add the command explain. I will execute that, and that gives me the query that I can then use in KQL format. So if I then copy that, if I had to execute this, it is going to give me again the same query results that we've got when we executed the SQL command before. So again, this is just to bear that in mind, that we can use the explain command, and that will help us in doing the building up the KQL query of SQL if SQL is our main language. If anyone hasn't used SQL before, it doesn't matter. We can start using KQL on Azure Data Explorer. So just to cover a bit pricing, so there are two pricing classes, I would say, inside Azure Data Explorer that one can use. So one of the um, uh, instance types of pricing is more directed towards storage. So it is ideal if you have large storage over queries, and the other is more computer optimized. So if you intend to do a lot of queries over a smaller data set, for instance, size, then you would go for the computer optimized instance type. It is billed by the hour, so technically it is fair priced. You can stop and only be billed up to that hour. And it also offers a developer tier that you can start developing on with cheaper rates, basically, but you cannot productionalize a solution on that. There is also a cost estimator that you can use before you start any instance, and you can calculate what one might be suitable for you depending on what you get as how many data, for instance, you need to ingest each month or within each period. That will help you decide which one to go for. So the next step will be demo. So let's start with the demo. Okay. So inside here, we will start working on a data set that we have ingested, which is named taxi trips. So it will be in here. So if I had to do a count of the size of the table, we will be dealing with over 1.5 billion rows. And as you can see, if I had to, for instance, do some aggregations over that particular table size, so we are trying to get here a count by year and month of, for instance, the number of trips that have been done, because this particular data set deals with taxi trips, and trying to get total amounts that costed each trip, total passengers by month, and we are basically splitting those by year and month. As you can see, those 1.5 billion rows, we were able to get the aggregations for each month, for each year in here, in 25.05 seconds, which is quite performant. One thing to show you also is that I am currently running on standard DS D12 V2, which is quite a small size, compute optimized. Obviously, if you were to execute that on something which is even more powerful, you will get quicker results than that. The data set that we are using, you can also access that from here. You can download it and ingest it inside your Azure Data Explorer. So to get also some other ideas of what we can do within Azure Data Explorer. So here we are going to calculate the average time of trips for a year by month, right? So for instance, in this case, I'm going to filter on 2019, trying to get the average trip time by doing a difference date of the dates of pickup and drop off in minutes and splitting that by month, basically grouping that by month in a windowed function. So we'll get the information back in um, a few seconds. As you also start executing a query, it will then also be saved inside your cache depending on how long you have set your cache for, and it will also be quicker the second time. So in here we have the results of the average trip time during the calculation by month for 2019. So to have an idea of what we can do with charts, so we want to, for instance, check the pickups by hour for May 2009 as a year. So in here we have the KQL query that is going to render a bar chart to show us the pickups by the hour and filtering on May 2009. So as you can see, we can execute that, have the chart. So this might not be the best way to portray this data. However, we are doing this in order to get some idea of what we can achieve inside Azure Data Explorer. And you can see here sort of the hour. So we can see that at 7 o'clock is the most time that we had pickups from, which is this particular count there, 900 to 9K. We can also produce a time series for a month aggregated by bin of 30 minutes. So what bin is, it can basically round up a particular date time up to a particular time interval that we specify. So for instance, we can round up each date time up to the hour or up to a certain minutes. In this case, it's going to be 30 minutes. And in here, we can see any taxi trips that have occurred for a particular month of the year, which is in 2009, February 2009. We are going to analyze the pickups for that month, rounding them up in 30 minutes intervals. And as you can see, it is quite a good way to analyze the data in a time chart and try to look for anomalies. So for instance, in here, we can immediately see that there was a drop during what seems like time during the day. So whereas normally it was dropping at night, so like 5 o'clock in the morning, 2:30 in the morning, normally in here between like 12 and 4:30, data pickups were always peaking, whereas here between 4th February it was quite a low. So if we want to zoom on that drop, we took the date that the drop occurred and the time that we think we need to start from analyzing from. So we took like 8:30 from here, and we analyzed for the next 12 hours over it. So we did a series. So I'm not going to go into the detail of a KQL query. There will definitely be much more help on Microsoft official documentation. And however, just trying to get a picture of what we can analyze and use Azure Data Explorer for. So in here you can see we can then go into more detail on that particular drop that has occurred and try to understand in more detail the numbers because now we have zoomed in and expanded that particular window more. So just to show also some other charts. So in this case, we are going to focus on this particular data set, which is dealing with this amount of rows. So we're going to we're going to do a time chart, another time chart. We're going to calculate the trips over this time period on a 1-day interval. And as you can see, it is quite fast when dealing with that amount of rows. And we can produce a time series graph and see that in here, for instance, there was quite a huge peak as opposed to the other days. So between September and October, there was a peak. So if we were to do these sort of things, it will help us get into seasonal trends and identify the peaks. It might be worth, for instance, checking if that is happening every year on the same period. Obviously, these sorts of charts will help us more in that scenario. With each chart, you can also go into table and be able to see the individual rows that are going to make up that particular graph. And there are also some statistics like memory cache, the data set, and so on. So another chart idea is related to comparison or correlation. So for instance, if you can compare one particular data set or even value with another, right? So in this case, what we are going to do is we have the IDs for the payment type in here. Now, we are starting with a sort of common table expression that we are defining what each ID will be referring to, and we are trying to compare what method of payment has been used the most between this particular period, which is 2016 to 2018. And if we run that, we are going to render a time chart and basically summarize the data into 7 days buckets. And we can see, for instance, here that credit cards have been much more used over cash during this period. And we can potentially see, for instance, and analyze there has been a drop here, but not as significant as here, and try to understand what might maybe caused some of those drops. So forecasting is also another way. So let's imagine we need to forecast some trips for the upcoming 2 weeks based on an 1 hour window. And we are going to focus on data that pertains to June 2020 and use that to then be able to forecast the following 2 weeks. We will be using some forecasting operators in here. So we have the data, and as we can see, so the orange bit is the forecasted part, whereas the blue is the actual data, and we can then try to forecast how that data will be in the coming 2 weeks. So another query that we can execute will return some aggregations also by weekday, for instance, apart from trip date, and calculating total trip time and the distance that we have already saved in there as an attribute, summing that up. So once this runs, we can also see another feature that exists within Azure Data Explorer. So I'm not sure whether some of you might have used, for instance, pivot tables in Excels or pivot tables in also other analytical tools. This is possible to be used within Azure Data Explorer within here. So when you have a tabular result on a table result, you can set to pivot mode. And for instance, if we now need to check the data by weekday, so let me check weekday and total amount, for instance, as you can see, the data in here can be pivoted the way that I want it to be based on the result table that I got before. And if you want to export the data, you can right click and export that to CSV, export that to Excel, copy it with headers. So quite similar of what, for instance, you can do in SQL Server Management Studio. External tables. So in this example, I had a storage account which has the a JSON file. So it does have a Yelp data set that you can find online. And we didn't ingest this data in here. All we did was we created a particular external table to be able to check over it. So if I go on in here, basically I can see the details that make up that external table. If I had to run a query of the rows, the number of rows that we can find within this JSON file, I can do that easily from here, and we got the result. So it is in the biggest data set. However, we need to bear in mind that it is being taken over JSON files. And if I had to parse the attributes of the JSON file uh, and check, for instance, some data within them. So, for instance, in here, if I had to profile the data to be able to also get a picture of what we mean by that. So if I take the first top 10 rows, right, in here there is a particular field named attributes, and this field, as you can see, is currently a string which holds data in JSON array. So some of them might not have all the same attributes. Good for kids, for instance, might not be present in all of them. Like this one, it's evident that it's blank. There doesn't even have any attributes. It's business. So if I want to be able to look at this external table, at the files, and check which business is greater or equal to 4 stars in terms of reviews, it is still open, and check, extend basically the attributes, parse them, and check which ones are marked as good for kids. I can do that in here. And as you can see, in the meantime, all of the data that we have inside the semi-structured JSON file is being queried, and we will get the results in here. So as you can see, we got the results back, and we can see which businesses have that fit that particular criteria. Once again, given it's an external table, we might not be fulfilling the power of Azure Data Explorer. However, it is still worth mentioning that this feature will be helpful in some cases. So in here, we are also going to render a chart from JSON files. So we are going to get the top 5 cities that has the most businesses which are rated 5 stars and which are still open. And as you can see here, based on the dataset that we have, we were able to render a chart from the JSON file with the data in here. So that is also one way that we can use Azure Data Explorer. So dashboards is also another interesting feature. As you can see, currently it is in preview. However, it is quite a helpful and yeah, good feature that hopefully will become part of Azure Data Explorer soon. So in here, if I go, for instance, January 2009 up till December 2009, I can set a time range, and as you can see, there are queries running in the background and displaying all those results inside dashboards. And this is quite a helpful way to visualize the data, as data will remain streaming in. The trends obviously will change depending also on the time range that we choose, but we can immediately know that for this particular time range, we had this total amount of trips, we had this average trip distance in miles, um, uh, we had an average amount per trip of 19.13. We can do a time chart and compare the vendor business with another vendor, and also compare the monthly percentage trips. So we know, for instance, that March 2019 had the most trips as compared to the other months in that year. Each dashboard card has a query. So if I go in here and do explore card, as you can see, there is a KQL query which is built and saved in that dashboard, and which is hence allowing us to run over and over again as we refresh. Another thing that would be also worth mentioning is functions. So just to quickly go through this, conscious that we are bound a bit with time. So if I had to take a look at this function, so we had created a function which is accepting a year and a month, and depending on what we give in that year and month, we will then execute and return the count of rows in there. So if I had to, for instance, call that function name by the name in here that we gave it, and supply a year and a month, we can execute that, and that will return the count. So again, if someone, for instance, is going to use that particular command often, we can save that in a function. It will be available in here, and we can then call it over and over again with different values depending on the results that we want to get. So that basically covers, I think, most of the demo points that I had to show. Just to also show you quickly, this is the Kusto Explorer tool that you can use. For demo, we focused on the Azure portal own user interface. However, this is also a good way to execute the queries. There are, as you can see at the top, various tools and features that can be utilized. But again, it's the same concept, connecting to a cluster, having the query here, and the results will show at the bottom. And also, just to show you quickly in Power BI, if we were to get the data from Azure Data Explorer and have that data inside um, uh, a Power BI report, we can do that from here, Azure Custom. We can connect to there. We will not go through the process of connecting to it, but we just provide a cluster, a table name, or a specific query, sign in, and we should be able to build in a report inside Power BI if we want to display the data in there. So back to the presentation. Um, yeah, so if we were to summarize, just to start concluding the session, so some distinctive features that we can basically mention about Azure Data Explorer, as we saw, is the ability to explore huge volumes in minimal time. Um, uh, Also, data ingestion capabilities, ingesting the data and be able to persist the data. Also, just to give you an idea on this, Microsoft internally has been using Azure Data Explorer since 2015. It then became generally available in 2019, but Microsoft has been running this and ingesting data from the likes of Skype, LinkedIn, Bing, and all other such technologies, petabytes of data to run over large clusters. So it does really fit quite well in there. Time series analysis, as we saw, they are quite a distinctive feature within Azure Data Explorer. Some advantages, summarizing some advantages in here. So again, even if we have less time to explore streaming data and raw data, it is not at the cost of analytical features and visualization potential, as we already saw through the charts and the results that we could get. Um, it doesn't require maintenance and administration in the same way as other analytical tools. It basically doesn't have indexing and it auto scales as you get along, and basically analyzing with its own easy query language, which is the KQL that we saw and that we used inside the demo. Some material that is worth also sharing: the ADX official documentation, the ADX sample cluster, so you can also utilize that link to have a sample cluster to run your very first KQL queries. And there are also some other URLs that you can use in the bottom bit for KQL, and a specific course that does get you up to scratch if you want to get like a bit of an introduction before you start getting KQL, even if I'm sure that you can start getting used to KQL with no previous knowledge before. So thanks for joining and for watching and listening. These are my details again, my email, the Twitter handle. I will also do my best to put over the PowerPoint presentation in the GitHub link that you can find in there, and also the link to the blog. Feel free to reach out if you have any questions on the session. But thanks for joining, and I wish you the best of luck. Thanks.